Good evening, everyone. Welcome to the virtual open house of the Colorado Street Bridge Barrier Enhancements Project, and thank you for attending. My name is Hayden Melbourne, and I'm Principal Engineer with Public Works Engineering, and I'll be acting as moderator for this evening's event. The format for this evening's 1-hour meeting includes an introduction of the project and design team, followed by a 40-minute presentation from Donald McDonald Architects. The remaining 20 minutes will be dedicated to answering questions from the community. Due to the restrictions of this type of meeting format, questions cannot be asked verbally, but rather submitted through a Q&A function. The button for this is located at the bottom of your screen. I'll be monitoring the comments and questions received during this presentation and will pose them during the Q&A session. Due to the time restrictions of the meeting, any questions received and not addressed during the Q&A will be posted and addressed on the project webpage. In addition, this meeting was being recorded and will be posted to the project webpage for viewing. So the purpose of this evening's open house is to educate the public of the project's history, design criteria, the review of the mock-up installations, and provide the information on future commission hearings before going to council. I'll begin the presentation now. Is everyone able to see the screen?
Yes.
All right.
Yep.
So joining us this evening are Zara Malloyan, Director of Public Works, Chris Markarian, our City Engineer, myself, Tiffany Chen, our Engineer and Project Manager, Steve Line from Donald McDonald Architects, Donald McDonald from Donald McDonald Architects, and Teresa Grimes, our Environmental Consultant. With that, I'd like to turn things over to Zara Malloyan.
Thank you, Hayden. If you can flip to the next slide, please. First and foremost, I want to thank all the participants that they have taken time off to participate in this community outreach for Colorado Bridge. I'm grateful for that, and I'll try to give the background information before I hand it over to Steve. Let's start with a little bit of background why we're here. In 2017, we saw an incredible increase in the number of successful attempts from this bridge. And on July 19th, Public Works staff presented to Public Safety Committee the history relative to the suicide statistics and literature on the subject and samples of several treatments. On October 18th, we went back to the Public Safety Committee, and at that meeting, I was directed to basically find a solution to the problem. For that purpose, I convened a task force, which included community members from historic preservation, first responders from police and fire, public health, mental health, architects, and engineers, in hope of in coming up with options for this problem. On September 2nd, there was an incident that it took 13 hours to negotiate an individual who was trying to commit suicide. That day, the city manager directed staff to get a PO and install a 10-foot fence, basically for the entire length of the bridge. Next slide, please. The task force then met several times, and we created a mission and vision statement. And I will read that so it kind of gives us the guiding principles for the task force. So the mission of the task force was to engage the community in developing solutions that will deter people from attempting suicide on Colorado Street Bridge while preserving its natural historic character and significance. And the vision that we came up with was to allow the community to experience and enjoy the Colorado Street Bridge and the Arroyo as a safe and beautiful environment now and in the future. Next slide, please. So let's discuss what was the problem that we identified. The Colorado Bridge was retrofitted. It had already a metallic or picket fence on top of a concrete bollard system. And even though it had a height of 7'6" it was not adequate to stop people from climbing that fence. Next slide, please. This kind of indicates the weaknesses of the existing barrier. The concrete baluster was about 4 feet tall. That was a foothold. And then if you stand on the concrete baluster, you had only 3'6" of iron railing to be able to get over to the other side. Next slide, please. We also found weaknesses in the seating areas, especially we call them alcoves. There were gaps between the fencing and the street light or the balusters for the lights. That was an easy attempt if you stood on the bench and then on the concrete baluster, you had maybe 2 foot of distance that you could climb on the other side of the fence. There are 20 alcoves on the bridge. There are 10 on each side. And this was another identified problem. Next slide, please. We also identified that at the beginning of the bridge, at the entrances, there were no fencing because the drop-off was not that much. People could easily climb this area and walk on the ledge, which we'll show you in the next slide. You could stand on that ledge, and it prevented, they could have walked easily to the middle of the span, and also it hindered negotiations with the people who were attempting to jump. The fire and police departments had a tough time because they would move on this ledge. Next slide, please. The task force then had community meetings, several of them, and we solicited input from the community, and we combined all these comments into 5 categories. And I'll go over them now, so it's very important for us to recap this. There were 5 categories where one were physical measures. There were measures that it would include physical alterations to the bridge. There were self-help measures. There were active measures, post-attempt measures, and changes to the environmental conditions. So some samples or examples of what these were. One was to install a vertical barrier, add end treatments to the bridge, modify the ledge. For active measures, there were comments that we could install speakers or intercoms on the bridge. There could be volunteers patrolling the bridge. We could have installed cameras and motion sensors. And then there were some post-attempt measures, which was if somebody was successful, there would be horizontal barriers and comments like planting trees and landscaping to soften the fall. The changes to the environmental conditions were like modifying the lighting and planting hedges on the bridge. And finally, the self-help measures were signs, phone lines, and text lines to assist with folks on the bridge. Next slide, please. The task force was then able to come up with a numerical value to the efficiency and effectiveness of these measures. And we put them in these categories. The red was the most effective, which is after all the research that we had done with all the other bridges that had successfully mitigated these type of incidents, they all had installed full-length barriers. I will not go through this. This will be on the PowerPoint and will be on our website. So the more stars was basically showing it was more effective, less stars was less effective. And which ones physically prevented people from jumping versus just being a passive system. So the task force finally came with these recommendations. It was, the task force recommended to the city public safety committee and eventually to city council to install a vertical barrier, which is 7 foot 6 inches minimum from the highest toe hold, and extend both sides of the bridge for its length. That means the entire length of the bridge will get the same treatment. Also, we recommended to have end treatments that was people from walking on the slope were prevented from climbing the bridge and walking on the ledge. And also, we left it open to have any complementary measures that we could add at the end. If there was any kind of signage or phone system or whatever that was at that time we had not researched, we could have added to this. So the task force recommendations then were given to the Public Safety Committee on April 18th. And then finally on April 23rd, we gave the same presentation to City Council. City Council unanimously approved the recommendations of the task force and directed staff to study the physical barriers. So when you see the rest of this PowerPoint, it kind of gives you an idea why we're not discussing other preventive measures, because this work was already done. And we had our guiding principles from City Council to only look at vertical barriers, which were the most effective at that time. Next slide, please. On May 20th, before that, we had an RFP issued to solicit input from all the consultants that had experience in the world of suicide mitigation off of bridges. And on May 20th, we went to City Council and awarded a contract to McDonald and McDonald Architects for their services. Then they started having community meetings and soliciting information on September 26th. That was our first community meeting. And then we had another meeting on October 29th. Then we continued our public outreach through Historic Preservation Commission, then on to the Design Commission, and finally on February 3rd to Public Safety Committee. Next slide. On February 3rd, the consensus among the Historic Preservation Commission and Design Commission was that we construct full-scale mock-ups of preferred 3 barrier design alternatives so people can visualize and see exactly the size and the effects of it before any specific design concept could be chosen. And then we know what happened after that. We had the pandemic. During that period, staff were still working on the mock-ups. The products were delayed, but finally we are here. The mock-ups were installed, and we're starting our community outreach, and we'll talk about the next steps. But at this point, this is just an overview of the project. And now I'm going to hand this over to our project manager from Donald McDonald Architects, Steve Line, to continue with this PowerPoint. So thank you for your attention. I appreciate that. And Steve, it's all yours.
Thank you, Ara. So welcome, everyone. I just wanted to introduce our team briefly. As Ara said, Donald McDonald Architects was selected for this. And we have quite a history in looking at and working with suicide deterrence on bridges, specifically the Golden Gate Bridge suicide deterrent. And I think what's interesting to know about that project, we studied every single bridge in the world that had implemented suicide prevention means and did a very comprehensive report on identifying both the actual mitigation strategy, what kind of barrier or netting might have been applied, got working with the mental health profession, looking at all of the various aspects of that before we worked on the Golden Gate Bridge solution. And so I just wanted to share that this is something that we've done a lot of research and work in, and here's 3 examples of some bridges where our designs have been implemented. Golden Gate Bridge currently is under construction, but the other 2 bridges are in place. And just rounding out our team, we have GPA Consulting, Biggs Cardozo, who was the engineer, as Ara said, that had done the initial mitigation and the retrofit of the bridge back in the 90s. They were part of that. And then we have our surveying and traffic engineers rounding out our team. The next slide, please. So how do you approach this? Is it just a thing that we're putting up on the bridge? How do you define or design this? So we use guiding principles of design, and we settled with these 3 core principles. The first one, the barrier has to be effective. And again, the direction that we got from council was to do a vertical barrier. That was, as Ara had walked through, this is the direction that came out of the task force recommendations. So at that point, we're looking at vertical barriers, and we do look for for effectiveness. So what's the effective height? The minimum that was provided was 7'6". We also they talk about toe holds, but we're looking at hand holds, footholds, and other means of climbing the barrier and making sure that we're sealing off the bridge ends. But equally important is we want to maintain and complement the historic character, defining features of the bridge. After all of the public input that we had on our first community meetings, as well as what the task force had heard, clearly the existing balustrade, we wanted to retain that. And then when we looked at the light pedestals, the light poles, and the fixtures, those are certainly character defining features of the bridge. And then we looked initially just to make sure we're considering everything correctly. Do we seal off the alcoves or the bench areas, similar to the way the chain link fence is doing currently? And it's just a broad consensus that the alcoves themselves and retaining the use of those alcoves, at least some of the use for them, making them usable for pedestrians and bridge was a clearly preferable feature that wanted to be preserved. I may add that when you work on historic structures, we're guided by what's called Section 106 of the Secretary of Interior of the United States has guidelines on how to address implementing changes or additions to historic bridges or any other historic structure. And the first guiding principle that they give us is you're not trying to copy or make a intervention that looks like it was trying to be part of the original design of the bridge. You want it to be complementary, but it has to continue to be part of modern materials, modern, kind of more of a modern, so that it clearly says I'm of a different era and time, but we do look for making the design itself complementary to the bridge. And we'll talk some more about that. And then with those character defining features, and I'm straying into the bridge aesthetics, this is what I'm talking about. We want to complement the Beaux-Arts architecture of the bridge, proportions, massing, solids and voids we'll talk about. And use of materials that provide transparency. And transparency, you're going to hear as I go through the presentation, is one of the key defining features that we felt has significance in the way that the barrier is constructed. And part of the mock-up is to help demonstrate the difference in transparency through some of the various materials that we're looking at. And then we also did some survey or just, anecdotal survey with the community to understand, and the groups that we met with, to understand the importance and the sensitivity to both the views of the bridge. So let's say you're looking at it from the Arroyo or from 134, and then the views from the bridge. You're from whether you're driving across a bridge, walking across a bridge, biking across a bridge. So those are the views from the bridge. And I think that by far, most of the experience that people have of looking at the Colorado Street Bridge is of the bridge, which we're going to talk about. And then I think informing all of these considerations is making sure that we still facilitate the first responders' ability to communicate and access jumpers that, for whatever reason, were able to breach the barrier. We did not want to prevent a direct means to get them back. And as Ara said in that one slide, even after 13 hours, they were able to successfully get somebody back. And so we did not want to impede that ability. So next slide. So just a few things on barrier effectiveness. We look at climbability. And so based on our studies, our analysis, we thought 7 foot 6 inches was really on the minimum, and that we find that being able to reach a horizontal element that you can pull yourself up and over 9 feet from a position where you can't jump, and 10 feet if your foothold allows you to stretch. Many people can jump up to 10 feet, and usually 9 feet is just outside the grasp of most people. So that's one of the informing criteria we used on finding an effective height. Next slide, please. Certainly it's just not reaching, but people are very adept at climbing. So we wanted to make sure that eliminating the ability to, let's say, climb lamp poles or shimmy between poles and the barriers and other methods of climbing and breaching the barrier. So that also informed keeping the ability to stretch and grasp distances to the top of the barrier around 7 feet. And this informed, and I'll talk about this later, where we had to position the barrier around the alcoves, leaving them open, but still protecting people from the ability to climb up the poles. The next slide, please. And then again, the historic and character defining features. I've talked about the alcoves, but also the pilasters that the lamps are sitting on. And then, as I mentioned earlier, preserving the balustrade. So these were key elements that we wanted to preserve as character defining features of the bridge. And yet each of these elements provide footholds and toe holds and the ability, as Ara said earlier, to climb on, to get up and over the barrier. So we had to take all of that into consideration. And one of the considerations we did look at is, what is the impact going to be to the lamps themselves? So their current height and proportions, again, character defining to the bridge. So what are some of the mitigation strategies we can use to retain and maintain that and still provide the effectiveness that we're looking for? And so we'll talk through that. We did at one time consider actually lowering the bases of the lamp poles to be more in line with the top of the balustrade, giving us a bit of an advantage. So the barrier itself may not have to be so high, but that barrier, that was in the earlier meetings decided that the height of the pilaster was more desirable. So next slide, please. So with this slide, I'd like to ask Don McDonald to just give us some overarching ideas on the guiding principles of the bridge aesthetics and a little bit about the bridge.
Thank you, Steve. I'm glad I'm still part of this team, of course, and that we're still wearing this major heritage bridge. What I like about it, there's a vocabulary out there. As Steve's probably mentioned earlier, the elements are up there on the bridge now are for transparency. And the theory is to continue with the vocabulary that's of the bridge, noting solids and voids, and bring that into the barrier in detail later. But the transparency is very important. I think that Steve pretty well covered everything, but I'm really concerned that the bridge has a long-lasting design to it. And so we'll work very hard to finish up this rail. And we're very sensitive over the past, at least my experience of the suicide business. So I think that this solution is well on its way. The transparency is very effective, I think, with those prototypes that are up there. But that's about it for me, Steve.
Thanks, Don.
Yeah.
Appreciate that. And so, as Don said, some of the character finding features in the bridge aesthetics that we're incorporating is there's that pattern and rhythm of the balustrades, the corbels, the elements that are coming off the top of the arches themselves, of course. And then there's a hierarchy of structure that's also implied in the bridge. And these are some of the elements that first you'll find that some of our posts and our vertical elements of the barrier are in alignment with these existing features. They do change over the length of the bridge depending on the span of these arches. So our fencing details or barrier details will follow that pattern, that rhythm, changing accordingly to match. And I'm going to talk as we get into some of the more of the mock-ups, what the intent was, and still some of the options that we're looking to refine the look of it to dial it in. So next slide, please. So I'm going to talk about options and mock-ups, but I just wanted to talk quickly about a few things. We had limited opportunities on the end of the bridge with the lamp poles to do a lot of mock-ups. We chose the two that are out there now, and we'll talk about those, A and B. And then we put two panels out in the middle of the bridge, fundamentally to do two things. To see how transparent these panels are looking, the views of the bridge. In the proportions we decided on the mock-ups at this point were to minimize the amount of material that's necessary to frame the barrier and to make sure that we're being as unobtrusive and providing as much transparency as possible, to the point that from a distance, some of the material basically disappear and you're just left with the frame. We know that there's some work left to be done to get the frame proportions a little bit better. But at this stage, we just wanted to see what our minimum options were to be able to still meet all the seismic, structural, and wind loads and yet provide the transparency. The other thing that we'll talk about in a minute is the materials, and I'll go through that in a bit. So so looking at the effectiveness, so that would be the height and the ability to climb or inability to climb. The bridge aesthetics, which has a lot to do with the transparency and the blending, and then as well as retaining the historic character defining features of the bridge, alcoves, the balustrade, and the lamp poles. So I'd like at this time to walk through some of the options. So option A was, I think, is a good example of all of these elements coming together. So as Ara said, it's the lamp poles themselves became one of the most common places that people jump. And so what we tried to do is look at a way that we could bring the barrier height at the pole. You can see it's quite a bit taller at the base than the balustrade is to the right. So what were our options to keep that element as low as possible and still match a barrier in this case, to the right of it? So we call this our curve straight option. Curve meaning that the barrier flares out around the lamp pole, retaining the ability for the lamps themselves to be visible at night with the bulbs, so that they still have prominence that they currently have. And at the same time, matching in this case, a flat panel or a straight panel to it that would extend between the panels. And just so those of you that drive out or walk out on the bridge to see these, we've painted the temporary supports in red, just so that it's understood those would not be part of the finished product, but for the purpose of the mock-ups, we're attaching them to the bridge using this temporary formwork. So that's why they're highlighted, but to the view on the right, you can see what they would look like without all of that supporting structure around them. So these are 14 feet total height, 10 feet high off the top of the balustrade, and then flaring out at the lamps. So next slide, please. And this is what we're calling option A. I wanted to point out, if some of you that go out there notice that we don't have any of the mesh material on this particular installation in the back of the lamps, and that is intentional. It keeps these becoming baskets, if you will, for trash and debris. It saves cost, and from a visibility point of view, it really, when you look at it from the other side, the mesh fundamentally disappears. So the idea here is that from afar, looking at the views of the bridge, it's really not noticeable, but that's why we're doing the mock-ups, to get everybody's thoughts on that as well. So that's this slide, and this is what we're calling option A. And we're going to show some just some different slides, some illustrations. This one is showing what the barrier looks at spanning between the lamp poles, and then how the lamp pole treatments in parallel work. So giving us first, the ability to keep the alcoves open and still have an effective barrier, eliminating the ability to climb the lamp poles. The detailing at the base of those is such that there's really not an ability to get a toe hold at the top of the pilasters. And we're retaining a 10-foot high barrier along the length of the balustrade, so that anybody climbing up there still has an extremely difficult time to get over that. Almost nearly impossible, we hope. And that we're going to talk about the materiality, but I'll just mention that this particular material we're showing is a stainless steel mesh, has a lifespan of 80 to 100 years at least, if not more. And it's meant to be highly transparent. Some of the early areas that we looked at was actually using glass panels or some type of clear panel, solid panel between the posts. But for wind loads, and there's a weight and a bunch of criteria, we felt we could get almost the equivalent transparency for most of the experiential elements of either driving on the bridge or viewing of the bridge, that it is very transparent. But again, we wanted to do the mock-up to make sure that that assumption is correct. So this is what we're calling option A. Again, here's the view on the bridge. You're going to see that depending on what material we selected, the transparency is quite good with almost any of the materials that we're looking at when it's perpendicular. But when you're looking along the bridge, the more vertical elements, like we'll see in the pickets, then that's what we get is called stacking. And pretty soon you don't see through the pickets anymore. And what you're really looking at is pretty much a wall of metal there without the transparency. So that's one of the key defining elements. Besides, quote unquote, the look of these barriers, there's also the functional difference in transparency. This is a view of the bridge. And again, you can see the patterning matching the corbels. And this is very simple, non-decorative. We're not trying to copy any of the arches or pick up, an element of the bridge, making this look like it was a permanent, it was installed at the same time the bridge was built. But at the same time, keeping it simple and keeping it transparent as much as possible, retaining as much of the visual character that we can. Next slide. And this just kind of gives you a view of it, a view of the bridge down from the park. And and you can start to see that the actual barrier starts to really blend back into the sky and becomes less prominent than the actual bridge architecture itself. Again, we see that as a benefit of retaining the actual character of the bridge by making that distinction of light transparent versus the color and the texture and the pattern of the bridge itself. Next slide, please. So our second option is similar around the lamp poles. Again, trying to keep the fencing as low as possible so we're not having to adjust the height of the lamp poles. And this has even come down almost 2 feet lower than the previous one. And we're able to do that because the mesh option to the left of it, in this case, in option B, is curved. So it curves out. And what's been found to be effective is by curving that outward, we can actually lower the overall height of it. And because that's lowered, and we think it's important to maintain what we call a constant horizontal datum around the top of it, we're able to lower the treatment around the lamp poles. In this version, we've tried to eliminate as much of the structural framing around the lamps as possible to provide, again, the most transparency. And
Steve, this is Don. I think that what's good about this one, the curve, is it does pick up the curve of the arches below the bridge. So there's a bit of a tie back in that existing vocabulary.
Yes, thank you, Don. And we also were very intentional of using a curve, a portion of a curve that minimized as much as possible what people would call the standard Caltrans fencing effect or the prison effect. So this is not a straight radius curve at all. It's a multi-radius curve, so it's got a much more organic shape to it, picking up on some of the architecture of the arches below, and really trying to minimize it and avoid as much as possible that, the sense that this is, it's trying to keep people, it's a barrier, curved barrier like a prison wall. And what it's much more meant to do is complement the arches and at the same time reduce the overall height of the barrier and the treatments around the lamp poles, while still retaining the full effectiveness of the barrier itself. Next slide. So again, the view of what this looks like. Certainly there's a whole spectrum of opinions on if this concept's successful or not aesthetically, but it is lowering the, like I said, the height, and the view of the bridge is almost the same. It's just when you're on the bridge, it does pick up that curve pattern. And then this is looking at it from below. And then the next slide, again, almost indistinguishable from, once you start to step away from the bridge. And again, it's as light and transparent as possible. So that's option B. Now, option C, we just did the panel on the middle of the bridge, and pickets. There was a lot of interest in looking at pickets, which is pretty much identical to what's out there now, only raised to be a more effective height. The problem with pickets is they're highly breachable. So this is really introducing many more options for people to climb over it. So like that parkour method, people shimmying up posts, this presents that opportunity much more than the mesh. And I'll talk about why the mesh, it's woven fine enough that you can't get your fingers or toes in any of those slots. It's an attractive solution, but as you can see here in this slide on the left, you can start to see that stacking effect I mentioned earlier, where the pickets start to fill in the field of view, and this is not really that much of an angle, and while the mesh maintains its transparency. So the idea behind the mesh is to maintain that transparency. So with the pickets, I think many people find this attractive when you're on the bridge, and looking at it at a standstill. But as you can start to see in some of these images, again, it's a wall of pickets. And so you lose the transparency looking through it. Not completely, but certainly much more so than you do with the mesh. If you go back to the previous slide, Hayden, real quick, you can see that it's a similar wrap around the lamp poles. These aren't flared. We can do this with mesh as well. So it doesn't matter whether this is picket or mesh. You'll just have to use your imagination filling in the different materials. But now you can see the height of this is 15 feet to accommodate these horizontal rails that the pickets require for constructability. And it pushes the lamp poles up quite a bit. So this option is the highest barrier and requires the most modification to the lamp poles. Thank you. So next slide. So again, this is just on the bridge. And then next slide. And so this is the view of the bridge. And as you can tell, when we do this, even though many people find this quite attractive, it is now competing a little bit more with the bridge itself. It's becoming an architectural element of more substance. And with that, then it's starting to be more part of the bridge and less a treatment. And I just throw that out there without an opinion which ones appeal the most to you, but there is a distinction there. Next slide, please. And similarly, where we saw that the mesh barrier material starts to fade away quite effectively, just the pure fact that there's more steel up there with the pickets, it certainly does not blend in as readily. So I just want to summarize some of the things that we just covered in these options. So to the far left, there's the existing height, and you can see some of the dimensions. This will all be on the website at the city, so that if you want to study this further, but this is the existing condition, and then the various alternatives and the various height differences associated with those. And again, if you go back to that slide real quick, so we're just trying to find simple terminology that implies the combination, and there's certainly the ability to mix and match some of this. So when we're calling curved straight, it's really the curved treatment around the lamp poles and a straight panel. So we didn't illustrate the panels around the lamp poles here because we show that in the mock-up, but this just shows a straight panel, A, but it would be curved around the lamp pole. B is curved around the lamp pole and a curved panel between those. And then C is a straight treatment around the lamp poles as well as on top of the barrier. So again, this will be on the website. I think it already is, but these are just some of the comparative tables that you can see with these various options. The effectiveness. So we think A and B are similarly effective. Again, B being a little bit less tall. C is the most tall and at the same time, the least effective. From a historic preservation, the character defining features, A, we're retaining the light pedestals at their existing height, but we're putting a base on the light pole of nearly 3 feet. Now, after we're looking at the mock-up, certainly we can adjust that to just exactly the right height. But the option B, again, by introducing the curve, we lower the overall profile. And so now we only have to lengthen our light base by about 1 foot. So that's less intrusive to the light poles. And then C, I think I've mentioned, we actually have to lower the light pedestals because we've got to get that bottom toe hold eliminated. So we do lower the pedestals and have a higher fence. So I just wanted to share this as a comparative table. So I want to talk a little bit about what we have up there in the form of mesh. Now, this mesh that we selected has a bright finish on it. I know that it's been highly reflective in the afternoon sun. That we can mitigate, but this was the available material that we had for doing the mock-up. So we went ahead and used it, but I do want to suggest that we're aware of and have means to eliminate a lot of that glare, if not all of it. But what you're looking at here, these are stainless steel mesh with the distance between those. And if you go out on the bridge, you can feel it. You can't get your fingers in there. You can't get your toes in there. So you're not climbing over this. The difference between the Trio and the Doka Barrette is just the prominence of the vertical elements supporting it. So the Doka Barrette is pushed together, but overall less. It seems to be a little less material than the Trio. But please take a look and let us know what you think. We did study many different patterns of this mesh, but we did want to make sure that whatever we chose first met the effectiveness characteristics, met the transparency characteristics that we were trying to maintain, and then in patterning and kind of the style is really experienced only when you're right up against it, and from a distance it kind of disappears a little bit. But please vote on or be taking a look at this. I think I talked about the mesh and the pickets. So the intent of these panels in the middle of the bridge to give you a sense of the scale, the proportion, the height difference, also the transparency, but these are really meant to also be looked at from afar. So, from the various vantage points around the bridge, the idea, and that's why they're out on the center of this, is so that you can take a look and see what they look like on the bridge from afar. I'm going to turn this back to Ara and the city team and talk about next steps.
Thank you, Steve. The next steps basically for us is to listen to the community and gather information. So from now till May 30th, 31st actually, is the period for folks to vote and basically take the survey. We are slated to go to Historic Preservation Commission on April 20th. We're tentatively scheduled for Design Commission on May 11th. And depending on comments we received from now on till we go to the Design Commission, we may have to alter some of the design concepts. For that reason, we don't have a final date for the public safety, but eventually, if all goes well, the first opportunity for us to go to the public safety will be sometimes in June, July. And after that, depending if the public safety committee supports the project, we'll go to city council. So for now, there is going to be plenty of time for community input. We may do one more community outreach like this, depending on what we hear from the folks if they need to hear this, although this is recorded and will be available on our website for everyone to listen. But if the need arises, we will definitely do another community meeting like this. So those are the next steps for us. Hayden?
Yes, Ara, we've received some comments during the presentation. I also wanted to go over the survey website that everybody can go to. If you go to cityofpasadena.net and search for Colorado Street Bridge, the first hit that you will have at the top of the screen is this project page. Over on the right side, you will see the contact information for giving your feedback for the survey, as well as there's an email address that goes to the design team for any questions that you may have after this meeting. Also below that is a link to upcoming events. Like Ara mentioned, for the Historic Preservation Commission, this is scheduled for April 20th. And then below at the bottom of the screen, you will also see all of our past agenda reports, as well as meeting notices and minutes from prior public outreach events. That being said, I will go through the questions that we have right now. This one's for Steve. The metal risers and the mock-ups underneath the lamp posts, they appear to be like what you put underneath a fire hydrant. How would you address raising the existing lamp posts, or would they be new lamp posts?
So we're looking at two things. Those are just, mock-ups. They're they're painted black right now, holding up the lamp poles. Those are not what we would use. And the two options are, depending on the height, is a pedestal that would be, again, complementary, a little more decorative than just the columns that are there now. So we would, in that case, pick up some patterning that's similar to the lamp poles. But the idea would be, and I know this is of interest to many people, is not modify the lamp poles themselves, but set them on the pedestals. We think for the taller options, like the pickets, we would consider as a likely alternative is keeping the light heads, the bulbs, and the arms supporting the bulbs as is, but then replacing the actual lamp pole in the same style that they are in now. So eliminating a pedestal and just lengthen the lamp pole. So those are the two considerations.
Okay. I know this was addressed in the meeting, but maybe you can expand upon it about the glare that's from the mesh in the afternoon sun. What kind of treatments would you put on that mesh to make it less reflective?
Yeah, so that's the first thing we do is actually it's in the composition, the alloy of the metal. So there are treatments to stainless steel that they make it integral to the actual composition of the alloy of the stainless steel. That I think some people may have seen stainless steel in different finishes. So rather than trying to put a coating on it or some other coating that will have to be maintained over the years, we start with the composition of the steel itself. That said, there are some very long-lasting other applied treatments to the metal that would all be done in the factory, of course, that can be applied to even further reduce that reflectivity. So we will kind of, as a mini mock-up, I think, get a piece of this. If the mesh is the actual material that is chosen to go forward with, we'll get probably a piece up there in that same light, in the afternoon light. And we are aware that it not only is reflective from behind, it's actually reflective on both sides. So we're aware of that, and we'll mitigate that.
Okay. Another question is the spacing between the pickets in option C the same as the present pickets? And specifically, and then how difficult would it be to cut through the mesh on options A and B if someone decided that was the best way to breach the fence?
So there's a couple things there that, so first to the picket spacing, what you're seeing in pickets, we didn't really want to design a whole new picket style. I think everybody's familiar with the picket. So the picket fence that we're showing meets all of the gap requirements between the pickets, but it is basically the same pattern of pickets that's out there now, only extended. So the spacing's the same, the patterning is the same that's on the bridge currently, just taller. In terms of the ability to break the mesh, what's interesting is with this pattern and the spacing, you can't really get a large bolt cutter on it as easily. I mean, you can get the very tips of some up there, but you're talking about, cable cutters almost. So it's a hefty piece of metal that you're going to have to cut through, but because they're spaced together, you can't get the jaws open too much. And the ones that can fit around there and get to the teeth, because the spacing again is tight, or it requires a much smaller tool, then that makes cutting through that. But there's certainly people can cut through that. There's, but not easy. You're not going to do it with tools that people might commonly carry, possibly even have in their garage. You could go at it with power tools. You could go at it with all sorts of different, cutters of, torches, but we don't expect that to be really something that most people in the state of mind that they're in when they make the decision to jump usually wouldn't carry that significant of equipment.
I think this was covered in the presentation, but I also want to just to reiterate and ask this question again, is that it was the committee wanted to save the alcoves. Was there ever any consideration to fence in front of those and have the fencing from the sidewalk so that to limit the height of the barrier?
Yes, so that was one of our very early studies. And if you do go to the city's website, and I think the first two community meetings that we held, Ara had put the dates and they're in this slide deck as well, you'll see that was a very early consideration that we did. We looked at bringing the fence down to be in front of the balustrades, pretty much identical to the way the chain link is now, and sealing off the alcoves. And overwhelmingly, the participation in those meetings and input from the Historic Preservation Committee and the city's, the community in the city, the preservation groups, it was strongly opposed is probably the best way to put it.
Okay. We have time for just two more questions. The first one I'm going to say is, can the pickets be thinner, more like the existing ones?
No. In fact, as I mentioned before, both the pickets and the frame around the mesh they're minimally sized for all of the structural loading requirements. So we went to the very minimum that we can do and still meet all of the code and requirements. So the pickets really can't be thinner. We pushed our structural engineer to the limit to make it as small as possible. And then the mesh, the frame of the mesh, we would consider actually changing some of the proportions to give it more of that feel of the pickets, where there's a little bit more definition between the elements. But what you're seeing there is pretty much as thin as we can get it.
Okay. And this last question I'm going to address to you, Mr. Maloyan. What are is there any appreciable difference in the cost between the options, and have there been estimates for each of them yet?
Thank you, Hayden, and thank you for that question. If people who have been following this project, if they recall, my promise was that we're not going to have a budget to design this project. as far as the budget to, or a limit in the dollar amount to determine the design. We wanted to find the best design which fit the characteristics of this bridge and also was the most effective. And we did not want to have dollars limit the design of this project. So I know it's kind of unlikely answer to be given by a city official, but because this bridge is so crucial and so important for the city, we did not want to have dollars limiting the design concept. So I believe after we go through this process and we determine what's the best option, then we can have cost estimates, and that would be presented definitely to the finance committee, not finance, but the public safety committee, because that would be one of the questions, and obviously to the city council. But till we decide what's the best solution for this bridge, we're not going to limit ourselves to the dollars, because this bridge deserves to have the best solution for one of the most historic elements in the city.
All right. Thank you. That we're out of time right now, but I wanted to remind everybody that this presentation has been recorded, and any questions that were asked during the Q&A that were not addressed will be posted on the city's webpage, as well as any addressing comments that were received to the SurveyMonkey. So that SurveyMonkey, we encourage everybody to visit the bridge to see the mock-ups in person. The SurveyMonkey will be up until Monday, May 31st. We will compile the results and all the comments, and we will present those to City Council at a date to be determined. Next, this project team will be presenting to the Historic Preservation Commission on Tuesday, April 20th, and then subsequently to the Design Commission on May 11th. As a reminder, again, please visit our website. Please fill out the SurveyMonkey. Your input is vital to the success of this project. As again, you can also use the email address that's shown on your screen, the Colorado Street Bridge at cityofpasadena.net. That goes directly to the design team, and we can answer any questions directly that you may have. With that, I would like to thank all of our panelists for being here, and you all have a good night. Thank you.
Thank you.
Thank you.
Thank you.